Dan Olds here, and we're talking with Ian Colle from Amazon AWS about their participation in the 2021 Asia Student Cluster Competition. How you doing, Ian?
Doing well, Dan. Good to talk to you.
Good to talk to you, too. So how did you guys get involved in this?
Wow. Well, we've really seen a need for kids to learn more about supercomputing. I mean, it's as being part of the HPC community for a long while now, we've seen the dearth of kids that have really taken a passion to this and have just been exposed to it. And it's affecting all of us as a community. And we see, as you know, the growth of HPC use cases throughout various industries and market segments, that the talent pool needs to continue to grow. And the only way that's going to do that is if we get kids interested in HPC. And that's where we saw one of the keys to that is participating in supercomputing challenges.
You know, and that's one of the things that you and I were just chatting about in our little pre-call is the number of schools that have a real HPC curriculum, very low, as near as I can tell. And you talk to some of these computer science students, and they haven't really heard about MPI.
That's true, or even lower level languages. I mean, well, we're talking like C, C++, and forget Fortran. You know, throw that in, and even concepts about what is a collective. You know, and so the more that we can get these young students exposed to this and get them hooked on how exciting an area it is to work, and some of the advances that we've made in hardware, but that if the hardware is, you know, a Ferrari and you've got software from a Chevy Nova inside it, guess how it's going to operate? And that's where I think it's exciting, because we can show the real impacts, and they can see that on the application performance from the codes that they're running as they go through these exercises.
Exactly. And what I found through doing my own recently finished competition and all the other competitions that I've done is that once they sort of see that, and they see that there's a tangible result from what they do, they get hooked.
Well, and especially, I mean, no offense to the hardworking web developers out there in the world, but when you look at the real world outcomes that come out of being part of the HPC community, I mean, this last year alone, the incredible steps that we've seen on COVID-19 research, the fact that we were able to take a vaccine from an idea to development to actual testing and execution, and to logistically deploying it within 12 months, something that previously had taken maybe 6, 10, 12 years, shrunk down to a year. And you can be a part of making sure that those kinds of advances in engineering and science occur. I mean, that's something to get exciting about. I mean, of course, there's some of us who geek out on the infrastructure and speeds and feeds and all that. But honestly, at the end of the day, it's about what people accomplish on the computers themselves.
And not just one vaccine, there's 3. And they're all being distributed. That's just amazing. And one of the games that I sort of played with some of these student interviews in talking to them is come up with a product, and I'll tell you how HPC helped seed it. And you can't really think of many products that didn't have anything from, you know, a lot on down to at least some HPC in it.
It's true. I mean, I think that it's an area that isn't well exposed in many cases. Like you said, we just take for granted that, you know, our cars get better miles per gallon because maybe they're a little more aerodynamic. I wonder how that happened.
And the materials are lighter.
Not
as much friction inside the engines. I guess they just trialed and errored that all the way through, right? So for the ASC21, you were providing cloud clusters, right?
We were. What we did is, especially given the virtual nature of, you know, trying to do these types of events in a COVID world.
Yeah.
We thought it was natural to do cloud clusters for these students. And what's nice about that is, we can work with them to instantiate them, run their workloads, experiment a little bit, play, and then tear them down. And we can spin up as many as we need for as many teams as we want. And we tried to, obviously follow the constraints that we would have had if we were in a physically constrained environment to, ensure that they were operating within the rules. I mean, the one area is like power envelope. We have to,
did you guys try and do
that? Because we have that, controlled at our level in our data centers. And it's one thing that's out of control.
But you control power by the row. And that was one thing that I did in my event was limit it to a certain number of teraflops of our peak hardware. And it sounds like you guys ended up at sort of the same solution to make sure everybody had a level playing field.
We did.
Okay. And I think that they came out with 4 nodes?
I don't remember the final configuration we wound up with at the end of the day.
Okay. But it was nice. It was a nice configuration. And I believe it had some GPUs in it, so they could play around with that. I want to say 4 nodes and 4 GPUs or something. Well, but I'll find that out.
Well, and what was nice was that on our side is we had an alum who's actually been a student participating in the student cluster competition, since went on to complete school, went and came to work for us at AWS, and has been like a kind of a mentor to some of the teams that we've worked with, and then was able to also be kind of the virtual mentor to all these teams.
Oh, that's great.
Hey, here's how you set up these clusters on AWS. And by the way, here's how I was part of that competition in the past.
That's great. And I know from talking to the virtual teams I talked to, they didn't seem to have any problems. It was different for them, and they had to get used to it, but there weren't any of the problems that I could have expected. So that says a lot about the guy you had working with them.
Well, and we like to think that we make it as user-friendly as possible. I mean, obviously there's some complexity with these types of machines and configurations, but we have products like AWS Parallel Cluster, which is open source, anyone can download, and that helps you instantiate your own HPC cluster right on AWS. And so that was one of the keys to
that would help.
Success of this.
That would very much help. And this was a difficult competition. They faced some really tough challenges with quantum computing simulation. They were doing pulsar detection, and that was with software that had Fortran in it, that had C++ in it, had Python in it, and who knows what else. In fact, one of the kids told me that he looked at the date of the last update of the Fortran portion. It was before he was born.
Oh, that's fabulous, though. To get kids exposed to just even different, each language, computing language, similar to human languages, has its own context and flavors and things that you learn from programming in it, much as you learn about a culture from speaking a different language. And so I think it's so crucial to get these kids exposed to those different programming languages.
Absolutely. Well, I'm really glad that you guys got involved. Is this going to be a deeper involvement for Amazon over time?
Oh, definitely. We're looking to support as many of the student cluster competitions as we can.
Yeah.
We feel that, the more that we can ensure that students know about HPC in general and know that HPC concepts can be executed in a cloud environment, on a cloud infrastructure, we think the better the future of the community will be overall.
It's also not a bad way to pick up highly motivated, very bright students.
And we're always hiring those.
Yes. Well, great. Thank you so much for your time. Really appreciate it.
You bet, Dan. Great talking to you.